What's going on, everybody? Welcome back to episode 6 of Python Noob, and today we'll be covering conditional statements and control flow statements. And before I get rolling, hit the like, subscribe, share. It really helps the channel overall. And I'm trying out a new setup today with a webcam and all that, OBS Studios. So let me know what you guys think of this too. All right, so let's do a quick review. What is a variable? It's basically, you can set x to equals 30. It's basically a way to manipulate data by setting something short for a number or a list, something like that. An operator is an equal sign, a star, the plus, the minus, the double backslashes or the slash front slashes. Basically allows you to combine variables and other information. Strings is text data, integers is just whole numbers, and floats are decimals. It can mean negative or positive. They're not whole numbers, they're decimal form. Typecasting, that one I don't remember off the top of my head. Lists, obviously a list of data, a list of basically you set a variable and then that variable has multiple items in it, and that'll be a list. List slicing is being able to add or append to a list, remove from a list, stuff like that. That's what list slicing is. A tuple is a list basically, but you can't alter the contents of the tuple. A dictionary, obviously, when you want to access something in a dictionary, you have to have a key. And then an input is just prompting the user for a question. What is your favorite food or something like that. And then print formatting is printing it off, printing off, an output. It's a way to output. So let's see how we did. This is just a review of what we have done so far up to this point, because like I said in the last episode, it's going to start getting more advanced. Okay, so variables, representations of values, contain the value and allow the value to be manipulated without having to write it out every time. Must contain only letters, numbers, or underscores. Operators or symbols, which are used to manipulate data. As you can see, those particular symbols, and they can be combined. Strings or text data. Integers or whole numbers. Floats or decimal numbers. Typecasting, which is the one I didn't remember off the top of my head. It allows you to convert one data type to another if the conversion is feasible using integer, float, and string. Syntax. Lists are collections of data, and then list slicing is a method of selecting values from a list, removing, appending. Tuples are immutable lists, cannot be modified. Dictionaries store data in key value pairs. Input, the input function gets an input from the user. And then print formatting. Triple quotes allow us to separate print statements onto multiple lines. All right, so now we're getting into this episode. Handling conditions. As you write your own programs, you'll need to carry out specific actions based on certain conditions. Conditional statements are used to evaluate whether these certain conditions are being met, and if they are being met, one set of actions will be carried out, and if conditions aren't being met, another set of actions will be carried out. Control flow statements are used to control execution of what occurs after a condition has been evaluated. Conditional statements, most commonly used conditional statement. Comparison statement, which is a double equal sign. It checks to see if two values are equivalent to each other. So B equals 9, C equals 9, B, and then the comparison statement, C, will be evaluated as true because B equals 9 in that case. But if B equals 12, C equals 4, then that'll come back as false. Other comparison operators, and this kind of works like basic math that we learned in elementary school. Less than is the less than sign. Checks if the value on the left is smaller than the right. Greater or larger than. Checks if the value on the left is larger than the one on the right. Less than or equal to, or greater than or equal to. So it works the same as, those symbols. These operators function like less and greater than, but also evaluate whether the values are equal. Exclamation equal sign is not equals, and it checks to see if two values are unequal. True if different, false if equal. Conditional statements. These comparison operators can also be combined with three different logical operators, which are used to tell the computer that it must take multiple conditions into account. The three logical operators, and, or, not. The AND operator is used to state that all provided conditions must be true for overall statement to be evaluated as true. If one part fails, the whole statement is false. So 7 is less than 2 and 3 equals 3. Obviously 3 equals 3, but that one on the left is false. So that whole statement's false. The OR operator is used to check if one part of a statement is true. The statement is true if one part is true. All statements must be false for the statement to be false with the OR operator. So 5 equals 5, 9 is greater than 12. Obviously 5 equals 5, but 9 is not greater than 12. The NOT operator is used to check that the next condition is false. A double negative, and it will return to return true if provided condition isn't true. So not 12 greater than 15 is true, if that makes any sense. And as you can see, I typed it into the Python syntax on this side in the Python shell, I should say. Not PyCharm, but the Python shell, just to test it out. So control flow statements are used to control how data will be manipulated according to the conditional statements provided. Typically, statements inside a program are executed in order of their appearance, top to bottom. The control flow statements alter this order. And the three control flow statements are if, for, and while. So first, if. It's used to allow a program to check whether a certain condition has been fulfilled. If the condition is met, the program will carry out the specified action. It tells the computer to do this only if the condition is met. Used in conjunction with the else statement. The else command is used to specify what computers should do if the criteria isn't met. It must come after if. So if R is true, you do S, and then on the next line, else, do T. The colon indent combo is how Python handles conditional logic and control flow statements. So it's possible to use multiple if-else conditional checks in one code block using the elif, else if statement. Can add as many as you wish. The final statement that exits the conditional checks should be the else statement. So if A is true, do B. Else if or elif C is true, do D. Elif E is true, do F. Else do Z. And then also possible to write if and else statements in line, meaning that logic is specified in the same line that executes as command, like assigning a variable or printing something. The writing statements in line means you don't have to break up control flow statements onto different lines. So outdoors, possible if weather is equal to, or in quotation, sunny, else not possible. The above code would set the variable outdoors to the value of possible if the weather equals sunny, if not, not possible. So let's review an example that will run in PyCharm. Suppose you're creating a game and want to ask a player to choose a difficulty level, and as you can see, I wrote this in PyCharm. So difficulty equals input, and then you choose 1 for easy, 2 for normal, 3 for hard, or 4 for impossible. And this is actually kind of cool. This is getting into some cool coding. If it'll ask the user for an input, and then you put either 1, 2, 3, or 4. If you put something else that isn't one of those choices, it'll tell you, please enter a valid difficulty. That's what the else statement would be in this regard. But 1 would be easy, 2 normal, 3 hard, 4 impossible. And then the above program prompts user to enter the level of difficulty. If the value isn't one of the 4 difficulties, it'll say, please enter a valid difficulty. And this is what it outputs when you choose 1. It's pretty cool. So control flow statements for loops and while. The for statements are used to start off for loops, used to tell the computer you want to keep executing a block of code until a specified condition has been met or is no longer valid. It's used to iterate through a series of items, meaning to proceed through a series one by one. It iterates through lists, tuples, and dictionaries, and that's referred to as an iterable. The syntax for looping is iterable equals 1, 2, 3 for x, and iterable print x. And as you can see, I did this right here, and it printed the list for me. Output the list. Okay, anyways, if above is a list containing 10 items, then the command above would iterate and print out each item one by one until the end of the list. So we have an example. Cats equals katana, fluffy, Ben. I don't know who names their cat Ben, but whatever floats your boat. And cookie. For cat in cats, print cat plus has been fed. So, you input that into PyCharm. Exactly. And for cats and cats, you print it out and it'll literally list off, your cats have been fed. Kind of silly, but it's kind of cool too. So the above code will get the names of the cats followed by has been fed. It will run through all the items on the list. We used cat as the name of the variable in the for loop. However, this could have been called x or I or anything. Python interprets the variable name we provide in that spot as variable that references the list entry in the loop being executed. Try changing the cat and notice, the cat variable, and notice the code will still execute no matter what you call the variable. You will need to change the name in the for statement and in the print function. We can also get an index of those values by using enumerate. To retrieve the index of a value with the enumerate function in a for loop, you can declare 2 variables, one for the value of the item and one for the index. So as you see, I wrote this in PyCharm. So this is the list. We've set the variable, this list, for index, item in enumerate, items list, and then print index and the item. And it'll print you 0, 1, 2, 3, 4, 5, and then it prints you the actual number 10, 9, 8, 7, 6, 5. You can loop through a dictionary in much the same way. However, the variable you provide will only capture the key and not the value. To access both the key and the value, you need to specify you want to access the dictionary elements after the colon. So obviously I wrote this over here. I wrote it in PyCharm. So drinks, and then you have your drink 1, which this is a dictionary, so you have to put the key. Drink 2, tea, and for the I in drinks, print the drink number and drink, and then format with the I and drinks I. And you can also use the items function, which will return the key and the data as a tuple. You can access the individual elements of that tuple, and that's what was done right here and right here. I'll pause it so you can look at that code and definitely test that out. You can also look through loop through strings, text data. A syntax example is stringy equals a string for I and string print I, and as you can see, it printed for me, and it printed on separate lines. Looping through a series of numbers can be done easily by using the range function, which will create an iterable list based on your chosen input parameters. The syntax example is range start and stop. If you don't specify a start value, the list will start from 0 by default. And ending the parameter, typo, specifies where the function should stop generating the numbers, but the value itself won't be included in the generated list of numbers. If a step value hasn't been provided by the default, it will be 1, and the numbers will be generated consecutively. The code below is expected to print out numbers 0 to 10 with a number on every line. So for x in range 11, and then print x, and I typed it in PyCharm. This is the output. The range is from 0 to 10. So the while loop is used to carry out a command or a group of commands while a condition remains true, structured very similar to the for loops. So an example is, while x is true, carry out action y. When we create a while loop, we need to create a variable that will be used to control the loop's executable. The loop will execute for as long as the variable meets the conditions we set. You must be sure to account for the potential problem of infinite loops, which will occur if the value of the provided variable is never updated or if it's always evaluated to be true. The loop will never finish, hence infinite. So a practical example for while, and yeah, I printed in PyCharm over here. So for while value equals 0, and while the value is less than 5, print part of while loop, value equals value plus 1, so the variable has been changed right here. Else, print the else condition. So as you can see, 0, 1, 2, 3, 4, and then it becomes 5 right here, so that's not less than 5, the new value, or well, in this syntax, it's equal to 5, so that's why this will print out the else condition, and this is the output that you get. So recursion versus iteration. Using a for loop to repeatedly run code until some end condition has been met is an iterative approach to solving a problem. Possible to create a function that calls itself and to have a function run continuously until it reaches the end criteria. It's called the recursive approach. The iterative, man, I'm struggling with that word. Iterative approach is Python's preferred approach, as there is a recursion limit. The break and continue. When you create loops, sometimes you want to end the loops early, stopping the loop when a certain criterion has been fulfilled rather than iterating through the entire loop. The break keyword used to end a loop early by exiting a loop and moving on to the next line in the program. So an example, as you can see, I typed it up here, fruit list, and you make a list of fruits, and then for the fruit in the fruit list, print fruit. If the fruit is apple, you print apple is in the list, and then you do a break, and then you print loop ended. The break can be used to avoid situations where an infinite loop would or could occur. Infinite loop is kicked off if the loop never meets the end condition. One event where this might occur is if values are continually added to a list and the loop is based on values that are currently in the list. Important to use the break statement to end the loop. The continue key can be used to skip the rest of the loop that follows the keyword. So the code which follows continue will only be skipped if continue criterion has been met. Has to be true. So the example is print only odd numbers. You make a list of numbers, as you can see here in PyCharm. That's the list, and for I in the number list, if I, and that's a modulus operator, 2, and that means it takes only odd numbers, is equal to 0, continue, and that'll skip. And you print I, so you're printing only odd numbers, and then it does 21, 35, and 19. And then it stops. Or skips the rest of the loop, I should say. Anyways, the TryAccept statements, these are used in conjunction to control errors that may occur in code. So the try is used to specify what computer should try. Accept is used to determine what should happen if the next if the operator cannot be carried out successfully. So try, action to try, accept, do this instead. A real example, so the value equals input. Please enter a value to divide with. The value equals the integer value. Try numeric 100, and then the floor division value, print numeric, and then accept, print error occurred, and valid value provided. As you can see, I typed it in PyCharm. This is our output right here. The program prompts the user to input a value that will be used as a divisor. If the value provided is not something that can be divided into 100, such as 0, an error will occur, and the accept part of the loop will be triggered, which is this. And the try block of the loop is ignored, and the accept block runs. Okay, so Python, and this is predefined errors. So Python comes with many predefined error messages that are built in. These unique error handlers cannot be used to control a variety of different possible errors, and they should auto-trigger when these associated error conditions occur. The built-in error keywords are and their use cases. So the value error is used when the value is of incorrect type. It can be used when a value entered needs to be converted into an integer, but the user has entered incompatible string or text data. Zero division error is triggered when trying to divide 0, which is impossible. The import error is triggered which we haven't gotten into yet, when Python has been instructed to import a module, but the module cannot be found or it cannot be imported successfully. The IO error is the input-output error, which occurs when IO operation cannot be completed, when an open command is called but provided file cannot be found. The index error occurs when provided sequence index is out of range of the sequence that has been provided. A key error is triggered when the dictionary key is provided but the key does not exist or cannot be found within the dictionary. The type error occurs when some function or operation has been applied to a data type but the operation cannot be carried out. And the name error occurs when a designated variable name cannot be found. So the predefined errors have an error message. The error messages can be displayed by setting the error as a variable and then printing the variable. So an example, try x equals 1 divided by 0, accept error as r, and then print r. When handling or when printing error message, the generic variable exception can be used to catch any errors not covered by other error handlers. So we're going to be working on an exercise, writing a program that does the following: creates a list or sequence. It uses a loop or a for loop to iterate through the list and do something with the items in the list. It breaks the for loop under some condition, and it includes some type of error handling. And then obviously we'll write our code before we look at the book's example. So obviously it's good to have the notes in front of you. So let's create a list, which I hope I can create a list without help, but all right. Let's see. Let's do a color list. Colors. So now we use a for loop to iterate through the list and do something with the items in the list. If color equals, let's just say red, well, let's do yellow. Then we'll break. Include some type of error handling. Oh yeah. So one thing you guys want to remember is definitely use the colons. I always forget to put the colons. Okay, so I fixed that issue. That's the cool thing about PyCharm, is it tells you, where your issues are, and it'll tell you exactly right here, where your issues are. Okay, so I think I completed my code. I cheated a little bit, but and then I edited it. Okay, so we have a colors list: red, blue, green, yellow. You ask the user to input another color, and for the color in colors list, try colors list.append colors. It'll add to the list, and then accept if the color is equal to, say, apple, which isn't a color. That is a fruit, silly. And then I'll break and end the loop. So let's try it. So enter color. Let's try gold. Okay. Now let's rerun it. Oh, okay. Let's put apple. Oh, well, it didn't even work. Well, I have to mess with this a little bit more, but I think you guys get the idea. So now we'll go through the books example. This is the books example. So let's see. What problems do we have? Oh, I forgot to write a colon again. I always make that issue or make that mistake. Okay. Let's rerun it. Enter a number to divide by, and it gives us all the numbers divided by 1, so that makes sense. All right, let's rerun it and see 0. Let's see if it triggers that. Yeah, starting loop and incompatible divisor entered. So it works. Nice. So we are donezo with our exercise, and this is the book's example again. If you want to try typing it out on your own, messing with it, definitely I'll keep practicing with this exercise too. So thank you guys for watching. I appreciate it. Hit the like, subscribe, comment. Let me know what you're thinking of the series. Until next time, later, Python noobs.